Hello, my name is Marcin Kubacki, I'm Chief Software Architect at Storware, and today's webinar topic is Backup and Recovery Strategies for Proxmox Virtual Environments. So let me start with the main features that vProtect supports. Everything is mostly around VM level or container level data protection. It's fully agentless so that you can easily integrate data protection layer with your Proxmox environment. We support application backup as well, so this enhances the general snapshot export approach with your custom scripts or native application commands that you would like to execute, so to centralize different approaches in a single product. Sometimes you would like also to have more checkpoints without the need to export data every time, so we also support snapshot management approach. On the other end, we are able to store into multiple backup providers, multiple backup destinations. This includes file systems, object storage, or enterprise-grade backup providers. So the general landscape covers multiple different platforms with multiple strategies for each one. Today we are going to focus on the virtual machines and containers running Proxmox environment, and on the other end we are going to store backups in multiple different vendors, multiple different backup providers. So let's take a look on the general architecture of the solution. So previously you've noted this was just a single box on the diagram. Here you can notice that technically vProtect consists of two main components. One is vProtect Server, one is vProtect Node. You can have multiple vProtect nodes, and these nodes are responsible for actual backup. So the data movers are called nodes in vProtect environment. So this is how you scale environment to match your needs. vProtect Server is mostly responsible for keeping metadata and handling general management tasks. So you can schedule everything, schedule all of the tasks within a single pane of glass, within a single console, or using REST API. Behind the scenes, this REST API is central point actually for connectivity. You can integrate external software, but we also internally use the same set of API calls on our vProtect server to collect necessary configuration data or store backup metadata. The general flows, there are actually two main flows in the engine itself, in the vProtect node. So this actually includes some sort of cloud or some other virtualization platforms, is integrating with appropriate, and let's say Proxmox in this case, or other vendors, other virtualization platforms. We connect to these environments, we gather necessary metadata, grab the actual data depending on the strategy, the data flow is slightly different probably, and the data actually ends up on the staging space from which we store later data into your specific backup provider. So this may include, for instance, cloud, or maybe it's basically a file system. Now, application backup is the secondary approach. It covers scenarios where you would like to, let's say, backup databases with the native approach. So maybe crash consistent backup is not enough for you. In that case, you are able to execute custom commands and grab specific, let's say, database backup with their native mechanism. So it's obviously consistent in that case, and the rest of the flow stays the same. So we are passing data through the staging space, later through some backup provider integration. vProtect Server is a lightweight server that basically focuses on the metadata. There is a small database in there, and there is an application server that focuses on the general management tasks. So depending on how these two components are deployed, obviously this will reflect this backup strategy, and each strategy has some specific requirements. While server can be deployed basically anywhere, vProtect nodes need to be deployed in a specific way. So for the Proxmox, we support basically two strategies. One they are right now referring is also used by the different other hypervisors like the Citrix, for instance, or libvirt-based hypervisors. So that was the original strategy that we supported in vProtect. Finally, it has also been implemented in the Proxmox to support QCOW2-based environments running on your Proxmox hypervisor. So the general idea here is that the node can basically run anywhere, and we are able to connect over SSH and reach to your data directly to your hypervisor. So there it actually allows us to do a few things. So first of all, we are able to directly talk with a specific hypervisor, so it means that we are able to load balance appropriate set of tasks. So this means that if we have 10 tasks, 10 backup tasks, and we have, let's say, 10 hypervisors that are going to be used during this particular backup job, we will try to access all of these hypervisors simultaneously, rather running all of the jobs on the first hypervisor and then going to the other one. There are some cons. This strategy obviously is currently limited for the QCOW2 based VMs on Proxmox environment. We don't have dirty block MAC support in the future now, but we are going to implement that in the future. This also means that we have to leave the last snapshot on the hypervisor for future incremental backups. The advantage is that we support incremental backups in that matter, so we are able to collect this data directly from hypervisor and do this simultaneously. Now the second strategy is the one that has already been implemented for a while. It's using native Proxmox mechanism using vzDump. This basically allows us to attach basically the storage to the Proxmox environment. This storage corresponds to our staging space. In this case, we ask Proxmox virtual environments to export appropriate image of the VM. So we are able to extend capabilities of the regular standard backup mechanism that you can find in the Proxmox virtual environment and export these backups using centralized management console found in vProtect to store in multiple different destinations that are available in vProtect. Currently, we support only full backup, but you are able also to exclude some drives, so you can at least save on the safe space by excluding unnecessary drives. Now, as far as backup consistency is concerned, in general, this is a crash consistent backup. So we create a snapshot, and then this snapshot is technically not consistent on the application level. So you may find sometimes that you would like to enhance it in certain areas. So while for Proxmox we support the pre-post snapshot or pre-post export capabilities, because this depends on the strategy. For the first strategy that I have mentioned with the SSH transfer, I'm able to create a real snapshot on the VM, and I'm able to invoke custom commands before and after snapshot takes place. I'm also able to quiesce file system because I know when the actual snapshot takes place. Now, with the old approach, vzDump behind the scenes created snapshot only on LVM-based VMs that especially matched containers, but not the virtual machines. So with using either quiet snapshot feature, which basically invokes file system freeze on the VM to have your backup to improve your backup consistency, you can also use the third mechanism, application consistent backup, using pre-post snapshot remote command execution. So that basically means that in order to make your backups more consistent, you need some sort of the way to quiesce your application, let's say quiesce your database, and resume it after snapshot takes place. In order to support more granular checkpoints, sometimes it is not easy just to export data all the time from your environment. Maybe it's just easy to keep a set of snapshots ready to be restored whenever you need them. So with vProtect, you're able to create snapshot management policies assigned to your VMs and keep just a set of snapshots on your hypervisor ready to be restored when needed. So with that particular aspect, you just need to remember that using snapshots, multiple snapshots on a specific drive may impact your performance. However, these snapshot chains may not really they don't need to be really long. You can actually just invoke one, maybe two snapshots extra on top of a regular backup, and this is going to improve significantly your recovery point objective. Now, I have mentioned application backup. It's not related to this pre-post snapshot remote command execution feature. It's the separate feature when we are able to invoke custom commands either on a remote host, but also on the node. Now, this allows us basically to integrate with basically any backup mechanism that you are able to invoke using some command line interface or some other tools. There are two main things actually to cover in here. So there are definitions and command execution configurations. So command execution configurations focus around the how do you invoke specific commands. So in that matter, you may say that I have prepared script that allows me to back up some MySQL database. It accepts certain parameters. And these parameters later result in which database you actually would like to back up. During the actual command execution, we instantiate them as the environmental variables. Now, parameters are, let's say, placeholders, and in the definition you later fill them up. So you can have multiple definitions using the same command execution configuration. So using the same script, you're able to cover multiple instances of your databases, for instance. Now, the source can be either a file, set of files, or the stream, so this helps you with different commands that are available on the market, so that you are able to enhance your backup on top of the running on the Proxmox virtual machines, and put your existing scripts that you have already prepared into vProtect console so that they are centralized in that case, while you are still able to store all of these backups in your central backup provider. Now there are three actually examples when you would like to use application backup. I have mentioned already basically the centralizing scheduling of the existing backup scripts for your databases or for other applications, but you also are able to enhance the Proxmox configuration backup. So the hypervisor level backup with this approach. So you're able to dump the configuration of the Proxmox just to be sure that not only your virtual machines are ready, but also ready to be protected, but also that you're able to dump metadata of the hypervisor itself. And already mentioned the databases as the one of the very primary scenarios where you would like to use application backup. So here is the example. I have an instance of my MySQL database. It's going to be executed remotely over SSH. So this command, whatever it is later mentioned here in the command argument, is going to be executed remotely over SSH, but it also can be executed directly on the node. A good example is actually with the MySQL dump command, is that basically it can be either executed against the remote host and is going to connect to some specific port like 3306, like it's standard for MySQL, or it can be executed remotely over SSH and dump configuration data there so that we can collect this data later over SSH. You can also optionally say if you would like to export data. Sometimes you can treat vProtect just as a scheduler, so you can just disable data export at all. And here is the example where the defined parameters can later be propagated to actual definition as the environmental variables. So the same script with specific set of parameters, later you just fill up the values for the environmental variables, and during the actual backup, this will be propagated to your scripts or the commands. Now you you should also think about how to recover these VMs later. So you have created a set of backups, set of schedules and policies, and you create periodically backups, but you also have to think how to restore them in case of a disaster. So imagine that you have one hypervisor where you have all of your VMs and the other one where you would like, for instance, to restore them in case of a disaster. So with recovery plans, you can define a set of rules. Rules are defined against the actual type of the virtual machine, type of the hypervisor. So in this case, let's say that you have several Proxmox VE rules, and they specify which virtual machines needs to be restored where and how. So in our case, we would like to take last successful backup and restore it to some hypervisor and specific storage in that case. Optionally, you can assign schedules, so it doesn't really have to be on demand recovery plan whenever your actual disaster happened. So that's the one scenario. The other approach is actually to periodically restore VMs on the other hypervisor to have proof that these backups are restorable. So in that case, sometimes you just select the option last successful, or in this case, last of, let's say, regardless of state. This will result basically in a failed restore because your backup, for instance, was not properly done recently. So because your last backup is not successful, it was going to fail, but you will have that information in the report. Rules obviously can also be defined against different hypervisors. You can have a single rule that matches, let's say, Proxmox VE, the other one matching different hypervisor type, and execute them at once, depending on your use case. So now it's time for a demo. So I have my vProtect environment in here. As you can notice, I have a single node. This single node is going to cover my Proxmox single hypervisor that I have on my list. Now, you assign nodes, so data movers to your environment, so you can scale up. In my case, this single node is going to handle obviously this single hypervisor. Now, once you have the infrastructure defined, you start with the inventory synchronization. So we have a separate inventory internally in vProtect that covers all of the virtual machines and disks that they have configuration, and later you define everything here in this console. Now, every operation is basically a task. So it is inventory synchronization that collects information from the hypervisor, and it is going to result in specific instances that I have defined in here. I have one VM that I would like to protect. It has specific backup policy already assigned. I have defined it earlier, and I can see that there is some backup history. I see that one of the backups have been interrupted. Some statistics around my backup size, backup time. Let's say that this one was specifically taking very long. It was waiting in the queue, so something maybe went wrong. But I can compare the amount of duration of the time that was needed to perform a backup. Maybe it gradually is going to be growing, so that means that maybe there is a bottleneck that we need to address. Calendar on the left helps me also to visualize what was the general activity around this VM, that I have some backups available just within a specific set of time. Some were successful, some restores were successful as well, and this gives me a quick way of filtering around the backup history. Now, in order to create a backup, I can just run a backup manually in here. So there is a backup icon. I would like to perform an incremental backup. So this has obviously created an export task in the queue, and because it's a two-step process, it's going to be export and store task that is being executed. Store is going to store data later in the backup provider. One very cool thing is that if your staging space is actually a file system, because it is, and your backup provider is a file system, these can be used together. And if it's a single file system, vProtect will basically move files instead of copying them. So store phase in that matter is going to take seconds instead of let's say minutes or hours. So I see that my export task is just started. So let's wait for a moment. In the meantime, let's just have a quick overview what I else can do here. So the strategies that I have mentioned can be overridden on the virtual machine level. So whenever you add hypervisor, you specify which strategy you would like to use, and I have these two strategies already defined. SSH transfer is currently inherited from the hypervisor level. For some VMs, you may just expect backups to be performed with the native mechanism because maybe it suits you better. For the others, you need to switch, let's say, to the actual SSH transfer, force it, or inherit depending on your needs. You're also able to assign snapshot management policies. So depending on your policies assignment and scheduling, you will end up with different set of snapshots. So the snapshot management will basically require some set of snapshots that are kept on the hypervisor according to your retention and your snapshot management policy. On the other hand, incremental backups using SSH transfer strategy, they require last snapshot to be kept on the hypervisor. You see that this one is current for incremental, and there is a green dot that marks that this snapshot is required for future incrementals to be performed. If you don't have any incremental schedule assigned, so vProtect knows that there will be no incremental backups scheduled for the future, then this basically is going to disappear. So you will have no snapshots kept on the hypervisor, and these snapshots also will not be kept with the single image strategy with this export storage repository approach. Now, I have completed my backup. Now you have several options what you can do with these backups later. So you can obviously restore it, specify which hypervisor would you like to choose, which storage, or if you would like to power on VM after the restore. Now you have also option to mount and restore individual files. So you choose on which node you would like to restore it, and with this new SSH transfer method, we also are able to not only mount and allow you to restore individual files, but also we are able to expose drives over iSCSI. So because you end up in this case in the raw format, we are able to merge appropriate backups for you and expose it over iSCSI, so we are able to mount it directly in some guest VM or target system and access files or partitions directly in there. That's especially helpful with the Windows guests, where you have NTFS file system and specific Windows file permissions. This allows you to basically restore them directly in the Windows machines, preserving everything that you need. Now I already have one backup mounted here, so in the backup mounted backups tabs I can go to the details, and there is a browse button. So as you can see, I'm able to walk around and download individual files. If this set of files is let's say very big, or there are many files, maybe it would be easier for you to just directly go to the node and copy using SCP or other tools that are available in there. Now other aspects. So we have talked about the backup, about the snapshot management. So snapshot management policies are pretty similar to the standard ones. You're also able to automatically assign virtual machines based on the regular expressions, specific environments. And you also, in particularly in the snapshot management policy, the rule that you define in here basically means how many versions or for how many days you would like to keep snapshots on the hypervisor. With the recovery plans, this is also a policy. Whenever you create a recovery plan policy, let's say it is a Proxmox recovery plan, you define set of rules in here, and let's say this is the rule 1. Specify which hypervisor type you would like this rule to be defined for. Let's say it's a Proxmox, and I have one VM. Optionally, I can specify schedules. I don't have any schedules set for now, and I can specify restore parameters for this set of VMs. So names can be generated that they can have some specific prefix or suffix, especially useful if you have the same environment being used for backups and restores. Now the applications is visible in a different tab, and you can see that there are some instances. So this is basically the definition of your applications. In our case, it's an internal database, a good example. Or execution configurations. Here are some templates as well, so you can clone them and customize to your needs that allow you to protect different environments, different type of hypervisors, different databases. And whenever you create a command execution configuration, you are able to specify arguments of the command, specify the data export, and parameters that I have already mentioned. So in our case, MySQL, for instance, requires a set of parameters. This includes the database names, paths where the script is going to be executed, some permissions, some log paths, etc. And whenever I create an instance out of this one, I will have all of these parameters propagated. And in our case, let's say this, I would like to create an application. It's MySQL. And I would like it to be this one. And let's say this is a fake host that is going to be used for this demo. Now here I'm able to specify values of these parameters. So this allows me to customize the actual database name, for instance, or the paths that I have mentioned. During the invoke, when your script is being invoked, we will have the values instantiated as the environmental variables, and you can easily use them in your command or script. Now we support multiple backup destinations depending on your needs. It can be a file system, object storage, or the enterprise grade backup provider. So this extends Proxmox native mechanism with support for such centralized backup destination support. And let's say this file system actually is a good example of one backup destination that allows you to have quicker backups because of this option to share together with staging space. It also allows you to enable deduplication. We support it with the video built into vProtect. Optionally encryption if you would like to. And you can, and if that is not enough for you, later you can use other storages. So that means S3 or S3 compatible. Some on-premise storage uses S3 connector, or the enterprise grade backup providers, especially IBM Spectrum Protect, or let's say Dell EMC, Networker, or Avamar. So that summarizes everything that I have for you today. If you have any questions, you can ask them now, or just type in the chat. I'm also, if you have also would like to collect some additional information, you can visit our website at Storware EU, or check our documentation. You can download vProtect for free. It's free for up to 10 VMs, and check it by yourself if it feels easy to use for you, and test it out. Okay, so because I don't see any questions, so thank you for watching this webinar today, and stay tuned for the next webinars.